Now friends, in this video lecture we will design the shaft on the basis of torsional rigidity or lateral rigidity. Okay, and in the previous video we have covered the design of the shaft on the basis of strength. Now friends, let us begin the topic. Now friend, when we design a shaft, then it is our requirement that it should not deflect too much and it should not bend too much, and the twisting of the shaft is not allowed too much. Okay, and these must be in a limit actually. uh, the bending is allowed in a limit, deflection is allowed under a limit, and the twisting is also allowed under a limit. So that must not exceed that limit, all these things. So we set a limiting value of deflection and twisting and can say that the deflection or twisting or bending of the shaft should not exceed this limiting value. So we will set a limit for this, all these things, the deflection, twist or bending. There is a limit and that limit should not be reached in the shaft. Then the shaft is said to be designed under torsional rigidity or lateral rigidity, we can say that. For example, suppose if the maximum deflection, lateral deflection allowed in the shaft is suppose 5 mm for applied loading condition. You can see this is the applied loading condition, and in this figure you can see this, and for this loading condition it is given to us that the deflection should not reach 5 mm. The lateral deflection must not exceed 5 mm. Then if our deflection due to the given loading condition is smaller than 5 mm, the design is obviously very safe, and if it is greater than 5 mm, then the design is not safe. Okay, similarly, so if this condition is satisfied for the deflection, then we can say that our design is safe under lateral rigidity. Now if suppose I say to you that the maximum angle of twist allowed is 0.25 degree for per meter length for this application. Okay, then if our angle of twist, because of this loading condition acting on the shaft, the angle of twist of the shaft is smaller than 0.25 degree per meter length, then the design is safe. If it is greater than 0.25 degree per meter length, then the design is not safe. So hence, if this set condition is satisfied for the angle of twist, then we say that our shaft is safe for the torsional uh, rigidity basis. Okay, so it is designed on the torsional rigidity basis. Okay, so here there is a limiting value of the deflection and limited value of the angle of twist allowed for a particular application of the shaft. So to design the shaft on the basis of a lateral rigidity, we calculate the deflection of the shaft because of the loading condition. Suppose this is our loading condition, then according to this loading condition, that is the bending moment and the twisting moment acting on the shaft simultaneously, for this loading condition we have to calculate the maximum deflection. Okay, now because of this twisting movement there will be no deflection, but because of this bending movement there will be some lateral deflection, so that we have to calculate. Suppose this is the shaft here. Now I will explain to you in a very simple way. Suppose this is the shaft and it is acted by a load W at the free end, and you can say that the deflection of this shaft delta max at the free end of the shaft is equal to WL square by 2EI. Okay, obtained from the deflection equation. And the permissible value of deflection, that is the limiting value of the deflection which is allowed in this application, is 5 mm. Okay, now so to find the diameter of the shaft, what we have to do, we have to equate the delta max, that is the maximum deflection because of this loading condition, to the permissible value of the deflection, which is equal to, and equate these to find out the diameter of the shaft, as we have done here. Okay, that we have equated this delta max with the permissible value of the limiting value of the deflection, and when you equate WL square by 2EI is equal to 5 mm, then the I here can be written as pi by 64 into d raised to power 4. Okay, so using this you can find out the length of the shaft will be known, W will also be known. So in this expression you can find out the value of the diameter of the shaft using this formula. So if the diameter obtained here is on the basis of lateral rigidity, so we say that our design is obtained in the form of diameter is on the basis of lateral rigidity. Now suppose the shaft design on the torsional rigidity basis is asked. Then suppose this is the shaft and a torsional movement is acting on the shaft. Now theta at the free end because of this loading will be equal to TL by Gj as shown by this formula, where T is the torque acting, L is the length of the shaft, and G is the modulus of rigidity, and J is the polar modulus. Now, if theta permissible, or the limiting value of the deflection which is allowed in this loading condition, that is, our theta must not exceed this value, okay, which is equal to 0.25 per meter length given for an application, for this application. So to find the shaft dimension, that is the diameter of the shaft, we have to equate this delta theta max with the theta permissible. So if you do this, then you can find out the diameter of the shaft using this calculation or these equation that I have written here. The J can be broken here in the form of pi by 32 into d raised to power 4, and when you equate all these things will be known, L will be known, T will be known, G will be known, and this is 0.25 per meter length. So length here will be taken as 1 meter. So you can find out the diameter of the shaft. So this diameter obtained is on the basis of torsional rigidity. So these are the things that you have to keep in mind while designing the shaft. So this was all for today's topic, friend, and if you like my video, you can subscribe my channel and also press the bell icon for the notification of the upcoming video. And also, friend, you can watch my video on the design of the shaft on the strength basis. Okay, thank you, friends.